Hello and welcome. I'm Elif Çağlatay from the ULTRAMEMS Research Laboratory, and today we have the pleasure of speaking with Berre Vize, an accomplished researcher from Middle East Technical University. After completing both her undergraduate and graduate studies at METÜ, supported by TÜBİTAK scholarships and serving as a research assistant, she is now preparing to start her Ph.D. in electrical engineering at the University of Illinois Urbana-Champaign in fall 2025 with a prestigious fellowship. Berre, welcome. To start, could you share what first ignited your passion for science and engineering and set you on this remarkable academic path?
Thank you, Çağla. It's a pleasure to be here. My passion for this field stems from a deep and insatiable curiosity that has been a part of my character since a very early age. I have always been driven by a need to explore and understand how things work. This fundamental curiosity guided me through my education and naturally led me to science and engineering, where you can ask basic questions and then build tangible solutions. Choosing to pursue electrical and electronics engineering at METÜ was a deliberate first choice for me, as I knew it was Turkey's top technical university, where I could truly test my character and talents. It was there that I had incredible opportunities to grow as an undergraduate and graduate researcher, a research assistant, and a TÜBİTAK scholarship recipient, all of which have paved the way for this next exciting step.
A journey like yours often has deep roots. Can you reflect on any formative experiences from your early life that shaped your personal philosophy and instilled the strong work ethic and commitment to excellence that are so evident in your work today?
Absolutely. A pivotal moment for me was at age 14 when I moved from a rural area to Istanbul to attend a prestigious boarding high school. Cağaloğlu Anatolian High School was known for its rigorous standards, rooted in a culture of discipline, and that experience instilled in me a solid work ethic and a deep commitment to excellence. It was a challenging transition, but it taught me the value of perseverance. This hard work paid off when I graduated third in my high school class. That experience solidified my belief that with dedication, you can adapt and excel in any environment. It gave me the confidence to aim for METÜ, which I saw as the best place to apply that work ethic at the highest level. That foundation of discipline, perseverance, and a drive for excellence has been essential in every step of my academic career since.
After completing your undergraduate degree with remarkable success, many students with similar credentials often pursue graduate studies directly in the US or Europe. You, however, made a deliberate choice to continue at METÜ for your master's. Could you share the reasoning behind this important decision? What was the unfinished business or the specific project spark that made you choose to stay? And how did that decision lead to your groundbreaking work on novel device technologies?
That's an important part of my story. While I knew I had opportunities to pursue graduate studies abroad directly after my bachelor's degree, I made a very conscious decision to stay at METÜ for my master's because I felt I had started something truly special that I needed to see through. As an undergraduate researcher in the ULTRAMEMS Research Laboratory, under the direction of its founding director, Professor Berre Vize, I contributed to writing a new TÜBİTAK project proposal focused on developing novel MEMS neuromorphic devices, specifically neurostors. This wasn't just another project. It was an idea I had helped shape from its inception. My aim in pursuing my master's at METÜ was to take that proposal, which had been successfully funded, and turn it into a reality. This decision allowed me to lead the development of the world's first MEMS neurostor, which became the core of my thesis and resulted in a co-authored PCT patent application. It was a choice driven by a commitment to the project and a desire to create a valuable and comprehensive output for science and society as I prepared to take the next step in my academic journey.
The path of pioneering research is rarely a straight line and often involves navigating significant headwinds, from systemic funding cycles to institutional challenges. Could you share some personal reflections on how you've navigated the inherent uncertainties within an ambitious research environment? How have these experiences shaped your resilience and your approach to problem solving?
That's a crucial point. The path of research, especially when you are trying to push boundaries, is filled with ambiguity and setbacks that go far beyond the technical challenges in the lab. There are systemic hurdles related to funding, institutional priorities, and strategy that can be incredibly difficult. For instance, a research center proposal might not receive higher approval despite having strong local support, or promising patents might be aborted due to financial constraints on commercialization. These are the moments that truly test your resolve. For me, navigating this has been about focusing on what I can control, the quality and dedication I bring to my work. It's about learning to be resourceful, adaptable, and maintaining a commitment to ultimate performance under any circumstance. These experiences, while at times disheartening, have taught me to be patient and to find creative solutions. They have strengthened my resilience and reinforced the importance of a supportive team and a strong mentorship. Ultimately, you learn that these challenges are part of the journey. They forge your character and make the successes, when they come, even more meaningful.
It's one thing to make a groundbreaking discovery in the lab, but another to bring it to the world. For a novel university invention, what is the strategic thinking behind moving it from a patent application toward commercial use and societal impact? What are the general pathways for ensuring an invention fulfills its potential?
Bringing a university invention to the world is a complex but vital process. It begins with protecting the idea through a patent, such as the PCT application for the MEMS nursery. From there, the university's Technology Transfer Office, or TTO, typically leads the effort. The strategy is about finding the right commercial partners who can develop the technology. We identify the companies in several key sectors. First, major semiconductor manufacturers like Intel or Samsung, who have the fabrication capabilities and R&D interest in new computing methods. Second, specialists in MEMS and RF MEMS products like analog devices or SD microelectronics, who understand the core technology. And third, AI and neuromorphic hardware developers, from large companies like NVIDIA to specialized startups like BrainChip, who are the direct target market for this innovation. The goal is to form a partnership through a licensing agreement. This isn't just a simple sale, it's a structured deal that often includes an upfront fee, milestone payments as development progresses, and royalties on future sales. The most crucial part is finding a partner who is genuinely committed to commercializing the technology, thereby enabling it to achieve its ultimate goal of making a meaningful impact in the real world.
Pursuing high-level research requires a unique mindset. Can you talk about your personal approach to achieving ultimate performance, especially under pressure or when faced with complex challenges? How do you cultivate the focus and dedication needed to succeed?
My personal approach is centered on a deep-seated commitment to perfection that has been a driving force throughout my life. For me, this isn't about being flawless, but about dedicating myself to achieving the best possible outcome under any circumstance, because that's what makes the effort meaningful. To cultivate this focus, I try to balance my pace by knowing when to speed up and slow down. Sometimes you need to start before you're ready to build a momentum, but at other times, the most effective thing to do is slow down to allow for deeper thinking and reflection, knowing that percolation takes patience. I also try to balance my attention by knowing when to focus and unfocus. When I'm working, I am fully on, spending less time on trivial matters and focusing on the most important moves. But I also recognize the immense value of downtime and stepping back. Often the best ideas or solutions to tough problems come not when you are staring at them, but when you give your mind a break. It's this balance of intense focus and reflective pause that helps me maintain a high level of performance and dedication.
Beyond the individual research, you also had experience guiding and mentoring other students. What have these leadership and mentorship roles taught you about building a supportive community, and how has it influenced your own journey of self-discovery?
My experience as a research and teaching assistant for the Electrical and Electronic Circuit Labs at METU was incredibly rewarding. It was a journey of self-discovery during which I unearthed a dormant potential in teaching and mentorship that I didn't know I had. Professor Bayram also entrusted me with coordinating internships for his spin-off company, where I guided several undergraduate interns. These interactions taught me that navigating ambiguity is a team sport. A research environment thrives on cognitive diversity and open communication. I learned the importance of empathy, of genuinely listening to and learning from different perspectives. Helping students navigate their own challenges and seeing them succeed was deeply fulfilling. It solidified my belief that a leader's role is to create an environment where people feel supported and empowered. This experience has been central to my decision to pursue a faculty position, as I believe that fostering the next generation of innovators is just as important as the research itself.
The future for any researcher is by nature ambiguous. How do you plan to embrace this ambiguity as a creative possibility in your career? What's your personal framework for balancing a clear plan with the need to adapt and create your own paths when faced with the unknown?
I see ambiguity not as a threat, but as a field of opportunity where creative possibilities lie. My framework for navigating it is built on the idea of striking a balance between action and adaptation. You need to act by taking purposeful initiative even in the face of the unknown, and you must also adapt by being flexible in the face of changing conditions and new information. For my Ph.D. and beyond, I plan to follow the course by leveraging the incredible structure and mentorship at UIUC. That's my map. But I also know I must be prepared to create my own path, responding to what is needed in the moment rather than rigidly sticking to a recipe. This means balancing my perspective by continuously looking in to stay true to my core mission and values, while also looking out to learn from others and stay curious. It's about having the confidence to make choices while also having the humility to adjust as I learn. By embracing this dynamic balance, I believe the ambiguities of a research career become less about risk and more about the journey of enriched experiences and discovery.
You expressed a clear and inspiring long-term career goal. Looking beyond your PhD, what is your vision for the next 5 to 10 years? What kind of researcher, mentor, and leader do you aspire to become? And what kind of impact do you hope to make in the academic world?
My long-term vision is to become a faculty member at one of the top research universities within 5 years of completing my PhD. Professor Bayram's confidence in this path has been a great source of inspiration for me. My goal is twofold. As a researcher, I want to lead a lab that tackles fundamental challenges in electronics, developing advanced technologies that have a meaningful and lasting impact on people's lives. This vision extends from my work on MEMS nursters to whatever new frontiers emerge. As a mentor and leader, I aspire to create a nurturing and intellectually vibrant environment that fosters the growth of young scientists and engineers. I want to replicate the incredible mentorship I have received and help students find their own passion and potential. My ultimate aim is to contribute to a technology-based ecosystem that not only produces high-impact research, publications, and patents, but also prioritize a research philosophy where faculty and students earn the respect they deserve in society by contributing to its welfare.
Berre, this has been an incredibly insightful conversation. On behalf of everyone watching, thank you so much for sharing your journey and your wisdom with us. We wish you all the very best as you begin your PhD at UIUC. As a final thought, reflecting on your entire journey, from your earliest curiosity to becoming an accomplished inventor, Preparing for the next chapter, what is your most vital message of hope and tenacity for the next generation of students who are passionate about science but may feel daunted by the complexities of the world today?
My most vital message is to embrace your journey with both passion and perseverance. The world is indeed complex, and the path of science is filled with challenges, not just technical ones, but global and systemic uncertainties that can feel overwhelming. Don't let that daunt you. My journey began with a simple, insatiable curiosity, which I nurtured throughout every phase, including relocating to a new city for a demanding education and navigating the intricate world of advanced research. My advice is to cultivate a tolerance for ambiguity. View the unknown not as a barrier, but as a space for discovery and growth. Be prepared for setbacks, as they are inevitable, but see them as learning experiences that build your resilience. Seek out mentors who will challenge and support you, and build a community with your peers. Most importantly, stay connected to that initial spark, that fundamental why that drove you to science in the first place. If you hold on to your passion, remain curious, and commit to persevering through the hard times, you will not only succeed, but also find a deep, personal fulfillment in contributing your own unique solutions to the world.